example, it says factorize completely x cubed minus 6x squared plus 11x minus 6. Hence solve this. So we are going to first factorize it completely, and then afterwards we shall solve. So we have our function f of x. I'm going to call it let. I'm going to set let f of x be x cubed minus 6x squared plus 11x minus 6. So it means in that case, if I want to factorize it, I must look for the factors of this expression. And remember, by factor theorem, the factors of those expressions are those numbers such that if you punch them where you have x, the whole thing will go to 0. The whole thing will go to 0. So in most cases here, you just have to guess, to keep guessing the numbers, such that you can find a few numbers as values of x that will take that guy to 0. Do you see that? So, in our case, it would be better, the first number to guess, look at the constant which you have here, and guess, your guess should start with at least the factors of that constant. So if you have 6, the factors of 6, we have 1, 2, and 3. So I'm going to guess around there. Let me begin with 1. Let me see if 1, x is equal to 1. If I let x is equal to 1, will f of 1 give me 0? This will be 1 cubed minus, this will be 6 plus 11 minus 6. But of course you see clearly that this is going to be 1 minus, in fact 1 plus 1, that will be 12. That will be 12. Then you have 6 minus 6 minus 6. That will also be 12. And that one still will give me what? Will give me 0. That means 1 is actually a root of the equation. So since I have gotten that 1 such that f of 1 takes the whole equation to 0, that means that therefore x minus this one here is a factor of our expression x cubed minus 6x squared plus 11x minus 6. Remember our advice, we have said it would be better if you begin by guessing any of the factors of our constant 6. So since now we have x minus 1 as a factor, it means x minus 1 can divide this expression. And if we can divide this expression by x minus 1, we are going to get a quotient. And that quotient will help us to further get more other factors. So let's try to see if we can divide this by the quotient, what shall we get? Let's try to divide and see. So I have x cubed minus 6x squared plus 11x minus 6. I'm dividing by x minus 1. I'm trying to get a quotient. So x cubed divided by x, that will be x squared. X squared times x, that is x cubed. X squared times 1, that is minus x squared. Subtracting, this is 0, minus 6x minus x. That becomes minus 5x squared, minus 6x minus. Then still plus 11x, minus 6. This is still divisible by this. 5x squared divided by x, I will have minus 5x. Minus 5x times x, still minus 5x squared. Minus 5x times 1, that is my plus 5x. If I subtract, this will go to 0. This is 11x minus 6x. I mean 5x, that's a 6x, still minus 6. This guy is still divisible by this. If I divide 6x by x, I will get 6. 6 times this, that is 6x. 6 times that is minus 6. If I subtract, I go to 0. That further shows that x minus 1 was actually a factor of that. That simply means that now, in this case, x cubed minus 6x squared plus 11x minus 6 is equal to x minus 1 into x squared minus 5x plus 6. I have factorized, but I have not factorized it completely. I need to factorize more the quotient. I need to factorize more the quotient. So the quotient is x squared minus 5x plus 6. Now, I need to find those numbers such that if I add them, I get minus 5. If I multiply them, I get 6. And those numbers are actually the factors of 6. I can use minus 2 and minus 3. Minus 2 and minus 3, add them, minus 5. Multiply them, positive 6. So, I'm going to express my 5x in terms of 2x and 3x, then plus 6, then plus 6. So, factorizing, this will be x into x minus 2. This will be plus, I can use minus, maybe minus x, minus 3 into, here remaining x, here remaining minus 2. I mean minus 2, since it is a positive, I can put the negative, so I have to make that a negative. So this one is common, I put out, then this one, and that. This one and that will remain minus 3. So x squared minus 5x plus 6 is equal to this, which is equal to that, which is equal to that. So in my equation here, where I have x squared minus 5x plus 6, I'm going to substitute with x minus 2 and x minus 3, such that x cubed minus 6x squared plus 11x minus 6 is equal to, this was x minus 1. Now this one is x minus 2 and x minus 3. So I have completely factorized. I cannot go beyond that in terms of factorization. However, the question doesn't stop there. The question says, do what? Hence, solve. So I'm going to solve when the equation is equated to 0. So if I'm solving, hence, if I have x cubed minus 6x squared plus 11x minus 6 is equal to 0, I'm going to substitute where there is this. I'm going to put my completely factorized expression, x minus 1 into x minus 2 into x minus 3, this is equal to 0. That means either x minus 1 is equal to 0, which implies that x is 1, or x minus 2 is equal to 0, which implies that x is 2, or x is equal to, minus 3 is equal to 0, which implies x is equal to 3. Therefore, my roots of the equation will be x1, which is 1, x2, which is 2, and x3, which is 3. And I have completely solved that expression. Let's try out this one. We want to solve the equation. We have said if we want to solve this equation, we need to factorize it first. When you factorize it first, then we can easily equate it to 0. So in our factorization, we are going to say let our f of x equal to 4x cubed minus 16x squared plus 9x plus 9. So we need to first factorize out this. In order to factorize it, we need to first guess the first factor. We need to guess at least the first factor. And we said in order to get the first factor, we need to get that number such that f of that number will take this whole thing to 0. So if you want to guess that number, we'll say that you are going to look at the constant with all the number which has no x in the expression. And then you look at its factors. You start guessing from the factors of that number. For example, here, the number we have is 9, whose factors are 1 and 3. So we are going to start our guessing from either 1 or 3 to see if any of them can solve the equation or can take this guy to 0. Let's begin with let x be equal to 1. F of 1, since 1 is our factor, you punch it there, that will be 4 into 1 minus 16, still into 1, plus 9 into 1, plus 9 still. This is 20, in fact this is minus 12, plus 18. This one cannot go to 0. So that one is not a factor. We neglect it. What about if we choose another factor of 9, which is 3? Let's try 3 and see what will happen. F of 3 is going to be 4 into 3 squared, 3 cubed, minus 16 into 3 squared, plus 9 into 3, plus 9. Plus 9 into 3 plus 9. This one will be 27. 27 times 4. 27 times 4. That is 108. That is 16 times 9. This is 144. That is 144. That is plus 27. Then plus 9. 27 plus 9. If you add this whole thing, it goes to 0. It goes to 0. That means that 3 is actually a root of the equation. It's actually a root of the equation such that x minus 3 is a factor. Of the what? Of f of x. Is a factor of f of x. Do you see that? By factor formula, we can say x minus 3 is a factor of our expression f of x, since f of 3 has given us 0. So we are going to look for other factors. So if we need to get other factors, we are going to divide our expression f of x by x minus 3 by x minus 3. Let's try that one and see what will come out. So using our long division, we have 4x cubed minus 16x squared plus 9x plus 9. Then we are dividing by x minus 3. 4x cubed divided by x, that is 4x squared. 4x squared times x, that is 4x cubed. That is minus 12x squared. If you subtract this 0, minus 6x squared plus 12x squared, that will be minus 4 minus 4x squared. That is it, plus 9x plus 9 plus 9x plus 9. Still this one is divisible by x. I will get 4x. 4x times x still will come back to 4x squared. 4x times 3, that will be positive now, positive 12. That will be positive 12. If we subtract, this will die, this will be 9x. This is x. Yes, this is 4x times 3. That is 12x. 9x minus 12x, that is minus 3. Is it 3? Yes, minus 3x. Still plus 9. Plus 9. This is still divisible by x, which gives us 3 negative. If you multiply, you will get minus 3x. If you multiply, you will get 9. And the subtraction will still give you 0. Therefore, we can easily say that 4x cubed minus 16x squared plus 9x plus 9. This one is the same as x minus 3 into our quotient, which is 4x squared minus 4x minus 3 minus 3. So we have factorized, but we need to factorize completely by factorizing the quotient. So we need to factorize this. So we have 4x squared minus 4x minus 3. We need two numbers such that when you add them, you get minus 12. When you add them, you get minus 4. When you multiply them, you get 12. Those numbers are 2 and 6. 2 and 6. If I have minus 6 and positive 2, if I add them, I get minus 4. If I multiply, I get 12. So this is going to be 4x squared minus 4. I can say minus 6x. Then plus 2x minus 3. If I'm to factorize, I bring out 2x here. Here I remain with 2x minus 3. This one I cannot factorize it any further. Minus 3. So, if I pull out 2x minus 3, here we have 2x, here we remain with 1. So that 4x cubed minus 16x squared plus 9x plus 9 is equal to, this is x minus 3. This is 2x minus 3. This is 2x plus 1. 2x plus 1. So I have completely factorized, but the question wants me to solve when this whole guy is equal to 0. So for that guy to be equal to 0, I'm going to equate this guy which is equal to this, which is equal to 0. So I have x minus 3 into 2x minus 3 into 2x plus 1 is equal to 0, because this is the same as that. That means either x minus 3 is equal to 0, which implies x is 3, or 2x minus 3 is equal to 0, which implies that x is 3 out of 2, or 2x plus 1 is equal to 0, which implies x is equal to minus a half. Therefore, my x1 is 3, x2 is 3 out of 2, and x3 is actually minus a half. So that is